In 4.9, we're going to learn about quadratic systems. We'll learn how to solve and graph both linear and quadratic equations, as well as how to graph and solve systems of quadratic inequalities. We have three different types of solutions when we're dealing with linear quadratic systems. The first option is to have two solutions, and that occurs if the two graphs cross twice. We could also have one solution if the graphs only touch once, or we could have no solution if the two graphs never cross each other. The first method of figuring out how many solutions we have is by graphing. First, we need to make sure that the equation of our line is in standard form. We need to subtract 4x to both sides, leaving us with 2y equals negative 4x minus 12, divide by 2, so y equals negative 2x minus 6. Then we need to graph that line. Remember, our negative 6 will be that y-intercept, and the negative 2 is our slope. So we'll start at negative 6 on the y-axis, and then move down 2 and over 1 to the right a couple of times, and we can go up 2 and over 1 to the left. Once we have a few points, we can draw our line in both directions. Next, we need to graph our quadratic equation. We need to start by remembering that our a value is 2, our b is negative 8, and our c is negative 2. So we can find the vertex. To find the x portion, we'll plug it into x equals negative b over 2a. So we're going to have negative times b, which is negative 8, over 2 times a, which is 2, and this gives us a value of positive 2. Then to find the y portion, we are going to plug it back into the equation. So we have 2 times 2, since that's the x value we just found, squared, minus 8 times 2, minus 2. That will give us a negative 10. So now we know that the vertex is at 2, negative 10, and we can plot that on our graph. And we're going to notice that we already have one solution, since both graphs cross at that point 2, negative 10. There could be a second intersection. We also need to graph that y-intercept. Remember, the y-intercept occurs when the x value is 0. So the y-intercept will be at 0 for x, and if we plug in zeros to both x's in the equation, we're just left with a negative 2. So we'll plot that point. Remember, we have the axis of symmetry that goes right through the vertex. So the symmetric point will come by going 2 to the right from the axis of symmetry. Now we just need to connect the points to get the shape of our curve. We only know 3 points exactly on our current quadratic function, but it looks like both graphs cross right here at 1, negative 8. For step number 5, we're going to write that down. We have 1 and negative 8 as a crossing point, and earlier we found that 2 and negative 10 was also a crossing point. You need to plug in each point into both equations to make sure that they come out as true statements. If we start with our first point and plug it into the first equation, we would have negative 8 is equal to 2 times 1 squared minus 8 times 1 minus 2. That gives us negative 8 is equal to negative 8, and it checks out. We need to plug it into the linear equation as well, which would be 4 times 1 plus 2 times negative 8. Does that equal negative 12? And it does. So we know for sure that the point 1, negative 8 does check out. We can repeat the same thing with the point 2, negative 10, but this time it will be, does negative 10 equal 2 times 2 squared minus 8 times 2 minus 2? And it does. So far, so good. Plug it into the linear equation, so 4 times 2 plus 2 times negative 10, does that equal negative 12? And it does. So now we know that both of our equations check out, we have graphed them correctly, and we have our two solutions. The second method we have to solve is by substitution. First, we need to make sure that both equations are solved for y. In the first example, that step is already done. Now we're going to use substitution, the fact that y is the same thing as negative 2x minus 8, we can plug it into y in the other equation, and that will tell us that negative 2x minus 8 is equal to negative x squared minus 6x plus 4. we're setting both equations equal to each other. Then we need to write it in standard form. We'll add 2x to both sides, and make sure you line up your x terms together. We will add 8 to both sides, and we'll line that up with the positive 4. That leaves us with 0 equals negative x squared minus 4x plus 12. Now when we get to step number 4, we have a couple options. We can solve for x using factoring or the quadratic formula. Depends on which method you prefer. I'm going to pick to use the quadratic formula in this example, but factoring would also work if you prefer. Our a value is negative 1, b is negative 4, and c is positive 12. If you forgot about the quadratic formula, go back and refer to 4.7. Plugging these values in, we'll have negative times negative 4 plus or minus the square root of negative 4 squared minus 4 times negative 1 times 12, all divided by 2 times negative 1. Simplifying under the square root will give us 16 plus 48, which is 64. That will leave us with 4 plus or minus the square root of 64, all divided by negative 2. And now we know we're going to have two different solutions. We could have x is equal to 4 plus 8, all divided by negative 2, or x can be equal to 4 minus 8, all over negative 2. That means x will be equal to a negative 6, or x could be equal to a positive 2. Now we can do step number 5, which tells us we are going to plug x into either equation, whichever one we prefer, to find what the y value is. I'm going to pick the second one. We had that y was equal to negative 2x minus 8. If we plug x in, the first one, y will be equal to negative 2 times negative 6 minus 8, which is positive 4. Now we know the second half of our solution. We know the x value is negative 6, but the y value now is 4, and here is the first answer. But we need to repeat it with the second x value. So y is equal to negative 2 times 2 minus 8, which is negative 12, giving us a second point of 2 for x and negative 12 for y. For the sake of time, I'm not going to do a check because we just did a check on the last example, but remember we're going to plug in both points like the check in example number 1. Now it is your turn. Pause the video and try solving this one on your own. Remember to follow the steps, take your time, and be careful with the mental math. On this problem, you do need to start by solving for y on the second equation. Once you set the two equations equal to each other and put it in standard form, we have x squared plus 2x. And this is going to be easier to use factoring than it is a quadratic formula. Pull out the greatest common factor, set both values of x equal to 0, and we find our first half of both solutions. Remember to plug them back into either equation to get the y values, which are right here, and then combine your x and y values together to get the final solution. Just like we could solve a quadratic and a linear system, we can solve two quadratic systems. And the steps are exactly the same as the previous example. First, we need to make sure they're both solved for y, which they are. Then we can set both equations equal to each other. So x squared plus 7x plus 12 is going to be equal to negative x squared minus x plus 12. Then we'll put the equation in standard form, subtract x squared with x squared, subtract the 7x with the x term, and the 12 with the constant. So 0 is going to be equal to negative 2x squared minus 8x. Then, step 4, we again have two options, factoring or the quadratic formula. In this case, factoring is going to be the simplest, so we'll pick that method. We can pull out a negative 2 as that greatest common factor, and an x with it, which leaves us with x plus 4 on the inside, all equal to 0. This means negative 2x equals 0, or x plus 4 is equal to 0, and x can be either 0 or x to be equal to negative 4. So now we have our x portions of the solution, but we need to find the y portions. Let's plug these both back into the equation. Y equals x squared plus 7x plus 12. Starting with x equals 0, y will be equal to 0 squared plus 7 times 0 plus 12. So really, y just equals 12. If we use our second solution, then y is equal to negative 4 squared plus 7 times negative 4 plus 12. This leaves us with 16 minus 28 plus 12, and together that gives us a value of 0. So we can attach our x portion to the proper y and connect the other x value with the corresponding y value. This means our first solution is 0 and 12, and the second solution is negative 4 and 0. These are the 2 points where both graphs will cross each other. The second method to solving two quadratic systems is by graphing. First thing we need to do is put both equations in our calculators. The first one is x squared minus 4x plus 5, and the second will be negative x squared plus 5. Now that both equations are entered in, we're going to press graph. And we can see that there are 2 intersection points where the graphs cross. To find out exactly where they are, we're going to press second and the trace button. And then we're going to select the intersect feature like we did with linear equations. See how it says first curve? We're going to move the cursor so that it's close to the intersection point on one of the graphs. And then we'll press enter. Then it moves the cursor to our second graph, and we're going to move the cursor again so that it's close to the same intersection point. Press enter one more time for it to guess. This will give us our first solution. I know that this says 4.9 e to the negative 15. That means that there's 15 decimal places in front of this 4. So really, it's basically 0. This means our first solution would be 0, positive 5. To find the second intersection point, we're just going to repeat the steps. We're going to press second and trace again, select intersect, but this time we need to make sure our cursor is moved towards the other intersection point. Once we're close, we can press enter. Then we're going to move it close to that same intersection point on the other graph, press enter one more time, and this gives us our second solution. 2 for x and 1 for y. Now that we've solved equations, we are ready to learn how to solve inequalities. And remember, inequalities have a wider range of solutions to them. It's no longer one single point, but a whole area that satisfies both equations. What we want to do is work with the equations one at a time. That's the key. Don't overwhelm yourself. Pick one and go with it. We're going to start off with the top equation. First thing we need to do is find that vertex. We can find the x portion of the vertex again by using that equation, negative b over 2a. Our b value is 6, so we'll have negative times 6, 2 times a, which is 2, and this gives us negative 1.5. To find the y portion, we need to plug that back into the equation. So y will be equal to 2 times negative 1.5 squared plus 6 times negative 1.5 minus 4. Using order of operations, we're going to find that y is now equal to negative 8.5. So our vertex is negative 1.5 and negative 8.5. We can put that on our graph, and it will fall right about here. Then we want to find that y-intercept. Remember, the y-intercept is always going to occur at our value of c, and it's when we plug in a 0 for x, we will get out just the constant. So the y-intercept is at negative 4, but then we need to plot that symmetric point. We went over 1.5 points from the vertex, so go over 1.5 points to the left, and now we have the shape of our graph. Now, since the equation is greater than or equal to, we are going to be using a solid line to connect all of our points. And since it's greater than, we know that we are going to need to shade above the graph. So we're going to shade all of the values that fall above the line, or all the y values that are larger than our vertex. Now we're going to repeat the same thing, but with our second equation. Again, we need to start off by finding that vertex, which will occur at x equals negative b over 2a. Our b value here is 3, so we have a negative 3, 2 times negative 1. Here the x portion is going to be 1.5. Plug that back into the equation, and y will be equal to negative times 1.5 squared. Make sure you put parentheses when you're plugging values in, plus 3 times 1.5. And our y value will occur at 2.25. So the second vertex is at 1.5 and 2.25, or 2 1/4. We're just going to guess. Here's 1.5, just a little bit above 2 is our other vertex. And now we need to know that y-intercept. If we were to plug in zeros for both of these x values in that equation, they cancel each other out, and we're left with nothing. So the y-intercept is just 0, 0. It goes directly through the origin of our graph. Then we can find that symmetric point, which will occur over at 3, 0. And now we're ready to connect our points. This time, though, it is going to be less than. And this tells us that we need to be using a dotted line when connecting our points. And then, since it's less than, we are going to be shading everything below our graph, or all the y values that are less than our vertex. Now we're going to find the overlapping area. This is the solution. All points that fall in there will satisfy both equations. So we have a pretty small solution area, but it's just right here in between the center of the graph.